purpose of today's event very much to explore the origins of successful collaborations, how they come about, how we can discover one another, and how we can empathise most effectively with our respective priorities and needs and build models that reflect those. What are the incentives to partnering? What are the risks associated with engaging? How might we achieve sort of symmetry? So that this is a term I've kind of discussed with various colleagues, whereby the partnerships are mutually of value and have a natural complementarity in ensuring that the respective partners are both getting something that within their context is very meaningful and beneficial, rather than being sort of lopsided where, for example, academics are doing work that maybe doesn't translate to a publication particularly naturally, or work that really has very little practical operational benefit for a government organisation that the academics are seeking to work with. And around that, what are some of the sort of resourcing questions I'd hope to explore as well. So what are the funding implications? Where might this work actually be funded from? What kind of people need to be involved in the development of these partnerships, and indeed what kind of skills and capacity can the respective organisations bring and offer? And conversely, where are the gaps in terms of skill on either side? And obviously for the urban big data centre, a really important commodity and a really important consideration is data. And often data can be a real glue to partnership. It can be a means of revealing an opportunity to do some interesting work. Sometimes the data can be common, but the use of the data can differ, and nevertheless that can translate to really successful interactions. So these are some of the things we hope to look at through the course of the presentations that follow. We'll see as well. We'll move on to the first session, which is a series of talks. So I'll perhaps invite my colleague from UBDC, Mark Livingston, and Kimberly Hose from Glasgow City Council to step forward. They're going to be outlining an ongoing collaboration between UBDC and Glasgow City Council around the automated identification and counting of a variety of objects from the CCTV sensor network. So I will not issue any more spoilers, and I will get this up on screen.
Okay, well, good morning, everyone. Thank you very much for coming along. So my name's Kimberly Hose. I work for Glasgow City Council, and I've been involved with the Urban Big Data Centre since probably the middle of last year. This project that we've been working on is linked to our CCTV infrastructure, and in particular looking at object detection and how that can support us understanding the impact of some of our projects in the city. Just to give you a bit of background, the actual project, the Avenues project, is a £115 million investment to transform Glasgow's city centre streetscapes. And that's about creating a network of continuous pedestrian and cycle routes. So it's quite an exciting project for the council. But quite often when we embark on these projects, we don't really think about how we're going to measure the impact. We just genuinely believe it's the right thing to do, and we've got the money, so we just kind of crack on, which is pretty much what we did. And it was the actual project originated, it was the Glasgow Centre for Population Health, who were looking at how they could evaluate the impact of this project and many other projects like this in the city. And I think originally they were looking at how do they count pedestrians on the avenues. And I think the first idea was to use counters, so manual counters. And then someone thought, okay, CCTV infrastructure, Glasgow's lucky enough to have, I think, 463 cameras in the city centre, all watching you. No, I'm only kidding. But actually, hardly ever watching you, which is part of why we're doing this. But yeah, so real opportunity there to use that CCTV infrastructure. But again, it was really okay. We're gonna look at the video, and someone's gonna sit and watch the video and sit with clickers and count people and cycles and cars, which worthwhile if you've got a lot of time to spare. And again, I think it was Mark who came up with the idea about moving it on slightly and you know, given where we are technology-wise, and you know, developing an algorithm. So using data to essentially train an algorithm to detect different objects, including people. Okay, I think there's a good 400 objects it can count, but I won't spoil that. That's definitely for Mark. So, just moving on. we're here today to talk about collaboration, and I think successful collaboration really does depend on everybody getting something out of it. Okay, and certainly at the start of the project, everybody was quite excited. Oh, we're going to be using this, really cool technology. We're going to be able to count stuff, and that lasts, a while. But really, in terms of longevity and ongoing partnerships, we all need to make sure that we're getting something out of it. Glasgow, as I say, well, we'd already started digging up the roads and we hadn't really thought about how we were going to measure whether this is the right thing or not. So that was quite an easy sell. Do you know what? We'll be able to prove, hopefully, that this is the right thing and that it's going to have a really good positive impact on the people of Glasgow in terms of how they use the city, how they transport themselves from one side to the other and through the city, but also just general everyday uses. Is there more people using these avenues, whether it's cycling or walking? For the university, it's a great opportunity for them to demonstrate the capability, the expertise that they have. And also just up there, we do have this CCTV infrastructure. And contrary to popular belief, there's not always a murder in every street corner, so it's not generally been utilised. And I think last, but definitely not least, opportunity to develop a relationship with the Urban Big Data Centre and Glasgow University. Okay. Some of the challenges, so we do have, once we started to sort of dive into it a little bit more, we had a number of project meetings down at Eastgate, which is our Glasgow Operations Centre, and we met with the CCTV technicians and operators to try and understand like practicalities, because obviously at the start it sounds really simple. We'll just get a copy of the footage and run it through the algorithm and hey, presto, we're sorted. What we had to understand was, in order for the research and the data to be valid, we had to ensure that the images that we were taking from the exact same place. We had to make sure that what we called home position, that we were all agreed on what home position was. So the camera, before it could take the image, had to come back to that same position every single time. So we had to, first of all, what's the best home position? So these cameras are, 360 degrees, full pan. We had to decide what's the best position. So we're looking at a street. We decided 3 cameras, I think it was, along the street. So one down, one up, one in the middle. And then really what position on the street are we going to capture the most information, whether that's cars, buses, cyclists, pedestrians. And we had to set that home position, which was no mean feat. We also had to make sure, we agreed frequency was about 15 minutes, so every 15 minutes we wanted the camera to go back to home position and take a snapshot. And we had to make sure that on the off chance that something was happening in the city and the operators were using the cameras to zoom in and to understand an incident, we had to make sure that there was an override functionality. Okay, so, and this did actually happen. We did have a real incident where operators were looking at a particular incident and the camera decided to zoom back off to home position to take its shot. Not what you want when you're trying to use that footage in a court case. So that was really, really important that we were able to build in an override function. Also, for the purposes of data security and GDPR, as I'm sure you're all aware, we were not allowed to let the images leave the operations centre. So it was really important that these images remain the property of Glasgow City Council, and even then we only keep the images for 2 weeks and then they're deleted. So if you want any footage, you've got a 2-week limit and then it's all gone. So we had to make sure that we were able to process the images and then get the information which we were looking for, which is the counts, and get them off to Glasgow University before we deleted the images. Okay. So I think I've mentioned some of this already. Glasgow City Councils, what was our role? We do have some technical people down at the Operations Centre, so they were responsible for setting up the home position, configuring the software and the technology to do that, to make sure that we had the frequency there, and to allow to set up the override function. picture of zebra. So if at any point in time the operators had to override the software, then what would happen is that the software would send a picture of a zebra to the results folder. Okay, so you would know that actually we were busy doing something, we were looking at an incident, etc. So you would know why there hadn't been an image captured. Don't ask us why we chose zebra. There's not been many. There's seen round about the city centre in the last few years, probably why. Yeah, and I suppose at the end of the day, it was important that every night when we were processing the images, we had to get the counts, the object counts, and we thought, right, how do we get this information? So it was really just automating that email and sending it over to Urban Big Data Centre to make sure that they had that every night. So that, again, just a bit of a fail-safe, you know, so that if we lost anything sitting in the operations centre, if we had any issues, then we've got that. It's been backed up by sending it externally every night. Okay, so I'm just going to hand it on to Mark, who brains behind the operation, and can go into a bit more detail.
Okay, thanks, Kimberly. Actually, I'll skip through a lot of the stuff on this slide because I think we've sort of covered it. But really, first thing I would say is that although we're describing what we did separately, we worked very, very closely through the whole process. So, for instance, in terms of, we worked very closely to identify the right cameras, the ones that were in the right position, but also the ones that wouldn't end up causing a problem for operators. But also we worked quite closely to identify the home position to maximise the number of people that were counted. And so our role was really to develop that programme that counted pedestrians, vehicles and bicycles, and then to automate the process, work with Glasgow City Council to automate that process, take the images from the folder where they were dumped, process them, and then put them somewhere else for deletion. And then the output file is emailed to us at Urban Big Data Centre. So this is Sucking Hall Street. It's a processed image. This is what the image looks like after it's been processed. The people you'll see. I guess the things to point out here is that the software has identified quite a number of people, but there are actually quite a number of other people, especially up in the background here, that don't get identified. It identifies vehicles quite well. It also identifies parked bikes very well, and that's part of the issue here. Because if you look at this, this is again Sucky Hall Street. If you look down here on the bottom right-hand corner, you'll see there's a person on a bike, but the software thinks that's a person on a skateboard, and so it doesn't count it as a cyclist. So it doesn't work. There's some work that we need to do here if we want to make this software work for counting people. That's the picture of the zebras that gets sent to, and yes, we're fairly sure there haven't been any zebras in Glasgow for some time. Okay, so we did a pilot study. So this was a 4-week study. I want to tell you a little bit about it because it gives you a sense of how well this software is working. The pilot was to look at the whole process. So we looked at nuts and bolts of how this all worked, how the cameras were working, whether they're moving back to home position, etc. We did some qualitative work with the operators and also some quantitative. We did some questionnaires. So I'm not going to talk I'm not going to talk about that really. Just to say that the impact was minimal apart from the one incident that. Kimberly's already mentioned. So really what I'm going to talk about now is the accuracy of the software counts, and how we measured that was we took 2 weeks, images from 2 weeks, and three of us went through a sample of those images doing manual counts, simply just putting dots on people and vehicles and cyclists. And what we were interested in here was that what impact, so I've lost my little pointer. I'm not very good at pointing, it's not very bright. So we're interested in cameras, the impact the camera might have on the software's ability to count people. We were interested in the time of day, The time of day was really about how many people were on the street. So we're interested in whether lots of people on the street made a difference. We're interested in light and dark. What does that make a difference to how well the software can pick out people? And we were interested in weather. Should just say that weather makes no difference whatsoever. Despite what we might think about Glasgow, I think there was only one photograph where the weather caused a problem, and it only blurred a part of the screen. So weather is not really an issue here. So I'm not going to talk about it. So this is a scatter plot of pedestrians. On the y-axis are the manual counts, and on the x-axis we've got, it's actually not showing all of it, but anyway, on the x-axis is the software counts. The black line here that runs along here is the line of equality. And the blue line is the regression line. And what you can see is that most of the counts are above that black line, which means that manual counts are counting more people, more pedestrians than the software count. But that's what we expect. What's more important here really is this blue line, the regression line. And what the regression line shows is that we've got quite a strong relationship between software counts and manual counts. So the software is good at allocating, counting people in terms of its relationship with manual counts, or the ground truth, I guess. So the correlation here is 0.9. If the correlation had been 1, all of the dots would lie right along the regression line. So the software is good at counting people, and it works right across the spectrum. So we broke this down a little bit. So these are correlation coefficients by camera and night and day. So the correlations, as we split them up, we expect the correlations to drop a little bit because the numbers will drop in each, and you're likely to get drops in the correlation counts. But just to talk about the camera, so what you see is that the different cameras, these two cameras, A03 and A82, the software doesn't seem to be able to count pedestrians quite as well as the other two cameras here, A47 and A66. An interesting phenomenon we noticed. So if you look at the top here, between night and day, you'll notice that software overall is better at counting at night than day. The difference is quite small, but if we look at the different cameras, some cameras are actually, the difference is quite significant. So in A47 and A66, these cameras were much better at counting at night time than they were during the day. But that's not true of all cameras. So these A47 and A82, the difference is the other way around, although not quite so marked. So there are differences here between cameras and their ability and the ability of the software to pick up people, and we need to understand that. And we're doing some work to look at why that would be the case. Why we'd get differences between cameras and why this night and day effect. It probably is something to do with light and contrast, but we're, like I say, we're working on that at the moment. This is just a very hastily done model. I don't expect you to be able to read this really, but the main message here is that when we put all the variables together in a model, what we find is that cameras A47 and A82, the software is poor at picking up the pictures or picking up the number of people. This is pedestrians. But things like, so those are the only two things that were significantly, and they're significantly poorer than at understanding or at picking up pedestrians. But things like nighttime, I'm sorry, I'm trying to point, but nighttime and day and night and time of day make no real difference to the software. The software is not really affected by that. So just to finish by talking a bit about the collaboration. So the first thing I would say is that as a group, there were definitely things that we think that were really important, essential things about the collaboration, but there were also things that I guess that we were not necessarily essential, but of real value to us. And so we've put some of these down. So the first thing I would say is the project had to have value to everybody. So we all wanted the information about the avenues, but also we were interested in how we could take this further. So not just how we count pedestrians, but maybe how we take this technology further. So there's an interest there and a value to both sides. There was also a strategic alignment here in that people in the council, senior people in the council and senior people in Urban Big Data Centre felt that this was something that was worth doing and worth pursuing. So we got support from above. There was a resource commitment from everybody. So we put in significant resource around the software and working with the CCTV people, but they did as well. And so we could see that we were all working together. And so it didn't feel unbalanced. So something that I think was probably more important than we'd like to admit, but the building of relationships over that period. So we've been going for about just over a year, and the building of relationships over that year has been really important. And now, as a group, we get on. The meetings are productive, but they're also fun to go to, and that makes a big difference, I think. The other thing is, in terms of working with a council like Glasgow, which is really large, finding the right people to work with is important. And we've been really lucky working with Chris and Kimberly, who were enthusiastic and keen to make this work. So that's not always been my experience of working in councils, and so finding the right people was really important. The other thing is agreeing roles and responsibilities, and we did that very early on. In fact, we signed a memorandum of understanding, sort of outlining what our different goals and responsibilities were, and I think that really helped put us all on the same page. So we knew where our responsibilities were in terms of privacy, about making the project work, etc. The other thing is agreeing timescales to suit everybody. Clearly, we're both different organisations are driven by different timescales. They've got different pressures of time at different points, but we work very hard to accommodate that, but to keep the project moving. And the next point, and I guess my last point, is that structure and governance were really important to keep this moving. And I can't stress this enough. When Kimberly came to the project, she really brought that to the project, and our meetings became much more productive. We had targets for each next meeting, things that had to be done, and people, the project moved along much more quickly, much more effectively once Kimberly came along and added that structure. So I'll finish there.